First, compute the average value pixel intensity value of a frame. What is the average pixel intensity of the edge? Then take the difference between these averages. That is the another difference we have considered for this particular work. And you can see when you do the differences in two different ways, the how does this difference appear, the sequence of differences. Here you can see that this is example for a frame duplication. So there are differences and there is some immediately there is a high difference occurring, and that again the differences are repeated from the earlier difference, that means frame differences getting repeated in the same way. That means a set of frames have been copied into many places. So this is a frame duplication. This is frame duplicate. This is the average of first pixel wise difference of each adjacent frames, and then the average means divided by the size. Here it is the find the average value of each intensity value of each frame, then take the difference. So here also you see the differences in the averages at 25 location. The difference is going high. That means from the smooth pattern, immediate spike here, and the same thing is repeated. Same differences are getting repeated, meaning that it is a duplication forgery, duplicated at many places. So this is, and this like this you can find out, you can see that there are spikes occurring in the differences for the frame insertion, frame deletion. These kind of spikes appear because the usual smooth pattern is getting disturbed when there is forgery. See here, this is the case with the frame insertion and frame deletion. When there is a spike, we see that we confirm that there is a forgery. And in order to find the spike in two different in all the videos, some may not be visible easily. That's why we use two differences. So these are the experimental results for the VIFFD dataset. And in this dataset there are totally 120 videos of each type. There are 330 each, and this is the accuracy we obtain for each type of forgery. Then there is another dataset we have used is the TD-TVD dataset. The references are given, and here also there are different number of videos for each type of forgery. This is copy at different kinds of copying and insertion deletion done, and this is the accuracy we obtain for the different types of forgery. This is another interframe forgery dataset created for experimentation for some authors for their purpose, and it is public. The reference is attached. So here also there are a different number of videos for each type of forgery, and we have shown the results for each type. So this is so we claim that this is an efficient and simple method for interframe video forgery. It is efficient because it can detect forgeries, whatever be the type, insert, copy, delete, whatever it is. Interframe forgeries it can detect easily, and also it is simple because with the simple differences we are finding the detecting the forgery, and it is fast and efficient, we say, because it is simple, can be computed easily, so the method works faster compared to the other state-of-the-art methods. It can be modified by incorporating detection of short boundaries and then analyzing each video segment. Because when there are short boundaries, then also it may cause the spikes in the differences. But in an ordinary video, if you analyze, we can see that there may be spikes occurring when there is a short difference. The video consists of many shots. So if you can find out a short boundary and then apply, if you can distinguish between normal frames and when there is a short boundary, separating each shot individually and then finding the applying this algorithm improve the result. Thank you.
So this was all about our sessions. There were total 5 papers which were presented. So Dr. Samir Patel sir and Dr. Ankit Patel sir, if you permit, then we can announce that the session is over.
Yes.
Okay, so Dr. Samir Patel sir and Dr. Ankit Patel sir, we are very, very thankful to you that you spared your valuable time for us and gave your important and helpful suggestions to the presenters. Once again, thank you so much for you, sir. Thanks for being with us. Thank you.
Thank you.
very much indeed.
So as per schedule, our next it was 1 to 1:30. It was a break, but as the schedule is running bit late, we are running out of schedule. It's 1:23. So we would start our session number 7, which is again a technical session at 1:30 p.m. So there would be a break for 6 minutes. After 6 minutes, we will start our technical session 7. Thank you. Miguel sir, are you speaking something but your microphone is muted? Good afternoon, all. It's 1:30. I know the break time or the refreshment time was very short, but we will proceed with our next technical session. And for that sake, we are welcoming Dr. Chandrasekhar Patil sir from MIT World Peace University, Pune, India, and Dr. Mukesh Patel sir from Charuset, Changa. So, welcome, Patil sir.
Yeah, good afternoon. Good afternoon. Thank you
Good
very
afternoon.
much. Yeah.
And thank you very much for spending your valuable time for us. And let us wait for a couple of more minutes for Mukesh Patel, sir.
Fine, fine. No issues.
Sorry, I had to take a break for lunch, so I did.
No, sir. No need to be sorry. Actually, official break time was 1 to 1:30, but as the
Well,
session
that's
was
the reason
delayed.
because I was having lunch with my son, so he
Yes.
was ready, and so I said, "Okay, chalo, let's just have lunch together."
No problem, sir. No problem. Absolutely fine. You are in time. So, sir,
Okay.
if you permit, should we start our technical session?
Yes, please. And I just
Thank
want to
you.
say, Dr. Patel, I want you to be in the driving seat for this because I had a long flight yesterday from London to Bombay and then Delhi and Delhi to Ahmedabad this morning. So I'm only
Oh.
half awake.
No
No
problem.
issues. Yeah.
Thank you.
Uh,
Okay, yes, let's start, please.
First we will do. First touch. Camera.
Chandrasekhar, sorry for
Yeah.
I just
No
joined
issues, sir.
right now. Actually, we need to take this our speaker to meet with the registrar sir and the provost sir. That's why.
Oh.
So like paper ID 21. Okay, just a minute. 215. Author of paper ID 215. Are you there?
Yes, I'm here. Sunlight.
Okay, so your name is.
Sunlight.
Okay, just a minute. So now you are presented, so you can share your screen and start your presentation.
Okay, thank you. Can you see my screen now?
Not here.
No,
Hello,
not yet.
can you see my screen?
No.
No.
It's not sure.
Oh, sure.
Yeah.
Now it's visible.
What about now? You can see?
Yes.
Yes, good enough. Yeah.
Okay, hello everyone. My name is Sanat Garim Kiatis together with Robert Damasavicius. We are the authors of Explainable Artificial Intelligence for Combating Cyberbullying paper. We are both from Lithuania. So we begin our presentation by addressing a pressing issue in our digital age, cyberbullying. Cyberbullying is not limited by geography, race, or socioeconomic status. It is a global issue requiring immediate and effective solutions. AI is a potential tool in detecting and preventing cyberbullying. However, those methods face critical challenges. One of the primary challenges the lack of interpretability. Thus, AI systems often operate in a black boxes where their decision-making processes are hidden. Even to their creators, this obscurity leads to reliable concerns, making it difficult for users and stakeholders to trust the system fully. Moreover, this interpretability challenges hinder the broader adoption of AI solutions in sensitive areas like the cyberbullying prevention, where understanding the why behind the decision is as crucial as the decision itself. Recognizing these challenges, our objective is to introduce explainable artificial intelligence, or the XAI, that aims to make AI decision-making process transparent, understandable, and trustable. Our goal is to create the AI systems that are not just powerful in their predictive capability, but also transparent and understandable to all stakeholders involved. The cyberbullying is a form of bullying that occurs through the digital devices and platforms, has become increasingly prevalent with the rise of social media and online interactions. It is a pervasive issue affecting individuals across the age groups, but notably severe among the adolescents and young adults. The effects of the cyberbullying are profound, ranging from psychological distress, anxiety, depression, to severe impacts on social and academic life. Moving on the technological front, AI-based detection techniques have been developed as a means to identify and mitigate cyberbullying. However, those methods are not without limitations. The traditional AI models, while effective in some respects, often lacks transparency in how they make the decisions. The opacity can lead to issues in reliability and accountability, crucial factors in sensitive applications like cyberbullying detection. The XAI represents a paradigm shift in AI development, focusing on creating models that are not only accurate but also transparent and interpretable. So let's explore some of the key approaches in XAI. At its core, first, we have explainable deep learning models. Deep learning, known for its complexity and layer structures, often presents a challenge in terms of interpretability. XAI approaches in this domain focus on simplifying those models without compromising their effectiveness. This can involve techniques like feature visualization, which allow us to see what features the models is focusing on when making decisions, or layer-wise relevance propagation, which helps in tracing the decision-making process back through the layers of network. The next, interpretability can also be achieved through feature engineering. This approach involves selecting or transforming features in a way that makes the model's decision more transparent. Lastly, we have hybrid methods, which combine multiple approaches to strike a balance between performance and interpretability. These methods might integrate simpler, more interpretable models with complex ones, or use the post-hoc interpretation techniques that explain the outputs of the black box models. The idea is to leverage the strengths of various methodologies to create a system that's both powerful and transparent. Having established the framework and the methodologies of XI, let's now focus on its application in a specific context of cyberbullying detection. When it comes to the application of XI, it's not just about detecting cyberbullying instances more accurately, it's also about understanding the why behind those detections. XAI enables us to focus on the reasoning process of AI systems, allowing us to discern why certain context is flagged as harmful or abusive. Comparing XAI with conventional AI techniques highlights some significant differences. Thus, the traditional AI models in cyberbullying detection often function as a black boxes, providing little to no insights into their decision-making process. This lack of transparency can lead to mistrust among the users that can pose ethical challenges, especially when false positives or negatives occurs. Finally, let's talk about the assessment criteria and datasets crucial for the cyberbullying identification. The effectiveness of any AI system, explainable or not, it depends heavily on the quality and the relevance of data it's trained on. For cyberbullying detection, this means using datasets that accurately represent the diverse form of bullying behaviors across various platforms. This dataset needs to be encompass different languages, cultural context, and communication styles to ensure the AI's effectiveness across a broad spectrum of scenarios. Moreover, the assessment criteria for those models must include not just the accuracy, but also the fairness, the bias, and also the quality of the explanation provided by the system. XAI driven intervention rules, the ability of XAI to provide clear and interpretable explanation for its decisions is crucial in a sensitive application like cyberbullying detection and prevention. It's not only aids in immediate detection and intervention, but also contributes to the education and awareness of the users involved, potentially leading to the reduction in cyberbullying incidents over the time. The real-time alarm system, this designed with the XAI principles, can provide immediate notification when cyberbullying behavior is detected. Second one is the XIA can empower moderators with defensible suggestions by providing them with the understandable reasoning for why certain context is flagged as a cyberbullying. Also, user-specific feedback is a personalized approach to intervention. With XAI, systems can not only detect cyberbullying, but also generate customized feedback for the users involved in both sides. XAI-driven strategies for cyberbullying intervention are critical as they provide clarity and reasoning behind the detection and the prevention measures. Let's discuss how the strategies can be applied to effective counteract cyberbullying, personalized feedback, and for offenders. This XAI can help in creating personalized feedback for offenders by explaining their reasons behind the identification of their behaviors as a cyberbullying, and it empowers the bystanders. Bystanders plays a vital role in dynamics of bullying. So XAI can empower bystanders by providing them the tools and understanding needed to identify and act against cyberbullying, by explaining the sign of bullying and offering clear guidance on how to respond. And it supports moderators, as the moderators are on the front line of managing online communities and preventing cyberbullying. The XAI can support moderators by providing them with the detailed explanation for flagged contents. This helps moderators make informed decisions about the context and intent behind posts, leading to more accurate moderation actions. The XAI-based tools for cyberbullying detection leverage the power of AI to identify and analyze instances in cyberbullying while providing explanation to their decisions. This dual capability is vital for building trust among users and administrators, as well as for refining the tools themselves. There is how these tools can function and benefits they offer: detection and analysis, transparency and trust, it continuous learning and improvement, customization and personalization, also the ethical considerations. In summary, XAI-based cyberbullying detects tools represents a significant advancement and online safety technology. By combining a predictive power of AI with the ability to explain its reasoning, these tools are paving the way for more responsible, ethical, and effective cyberbullying mitigation efforts. When it comes to cyberbullying detection, datasets play a crucial role in training and validation of the AI models. The quality, variety, and representativeness of these datasets can significantly impact the performance of cyberbullying detection systems. Here are some datasets for cyberbullying detections. That's the Formspring.me, Twitter, MySpace, Wikipedia talk page, and also the SKFM. In conclusion, our findings underscore the significant role that explainable artificial intelligence can play in the detection and prevention of cyberbullying. XAI transformed the landscape of cyberbullying intervention by providing transparent and understandable AI processes, which are crucial for earning the trust of users and administrators in the digital platforms. Looking ahead at the future of explainable artificial intelligence and cyberbullying detection, we are on the cusp of significant advancement of challenges. In conclusion, the future of XAI in cyberbullying detection is promising, but will require careful navigation of technological and ethical landscapes. The advancement in this field have to potential to create safer online communities, but only if we are able to successfully integrate these new technologies while addressing the inherent challenge of bias, fairness, and ethics. Thank you. That's all my presentation.
Yeah, thank you, Samit. It's a nice presentation, and I have
Thank
some
you.
questions on this. Is it's a literature review paper or it's an experimental paper?
That's a literature review paper.
Oh,
No experiment is done. It sounds.
okay. Suppose you have to do the experimentation of this, then how
Yeah,
you
and
are
the
going to
picture
go?
works. We are considering it. We are starting to do some experiments actually.
Okay. So cyberbullying simulation we are going to do or experimentation you are going to do? What?
The experiment we are doing now is on the intent detection, sentiment analysis, and the XAI is applied on that. But cyberbullying
Okay.
is the next chat.
Okay. And how many papers you have reviewed for this? For this work?
More than 12, around 50.
Okay. Fine. Over to you, sir. Yeah. Mukesh?
Well, I don't really have a question. I mean, mine was also similar question. Is this like more like a position or a conceptual approach to this? But more specifically, XAI, are there any existing implementations where we have like AI models, as you said, which are kind of dynamic and complex, which have been explained? Because a lot of what you're saying is relying on the fact that well, XAI is a concept. In its practical application, I'm not sure where it has succeeded in enabling us to explain the AI part of it.
There is some like libraries. What we are doing right now in another paper is the shop. If you heard about the shop, so it highlights the text, like which part of the text is have the more percentage for the decision made on one part. So it's visualize the text and it shows like which part of this text is contributes most for the decision. So there is such kind of implementation already.
Okay. Yeah. That makes sense. Okay, I understand now where we are regarding XAI. Okay, good. Thanks.
You're welcome.
Thank you. May I invite next paper author, Dr. Patil and Dr. Patel. So next paper is a 260. Is author of 260 present here?
Yes, sir.
Please raise your hand. What's your name?
Yes, sir. Yes, sir. I'm available here.
Okay,
My name is
okay.
Khushbu Mishra, paper
Okay.
number 260.
Just a minute. Let me make you the presenter so you can share your screen. Okay,
sir.
now you can share.
Okay. Is my screen visible, sir?
Yes.
Is it fine?
Yes, everything is fine. You may start.
Okay. Good afternoon, everyone. I'm going to present our topic XDeepID, an explainable hybrid deep learning method for enhancing IoT security with intuition detection. I have done this work by the help of my friend Gautam Bhagat under the guidance of Dr. Karima Datta ma'am. This is the outline of my paper, abstract, introduction, related work. Basically, we have proposed three basic methods: gated feature representation learning, Shapley value, and the explanation model. Here we have used global and local models. And the third one is Lime Shapley method for the final prediction. Then I will conclude my session by explaining experimental results. So first of all,
Khushbu, sorry
yes,
for
sir.
interrupting you.
Yes, sir.
May I request you to turn on your camera?
Yes, sir.
Actually, it's for like, we need to have this for proof that you have presented your paper.
Okay, 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 sir.
If you can turn on your camera, then it's fine. Otherwise,
Yes, sir, I can. Am I visible?
yes, yes.
Yes.
Please carry on.
Now I can. Okay, okay.
Yes.
Okay, I have done my work for intrusion detection. So basically, we know IoT device typically establish connection through wireless network. So there might be a chances of unauthorized access to private information via eavesdropping or communication channels become possible due to their constant computational capacity and compulsory power requirement. IoT devices are unable sustain intricate security framework. For this, we have formalized the intrusion detection system by using explainable AI framework. Hence, the main objective of this work is to enhance the transparency and durability of intrusion detection system on the basis of deep learning methods for Internet of Things network. So these are the related works I have done for this work for intrusion detection and for the Internet of Things by using deep learning methods. And there are very drawbacks still exist in the research of in the state of the art methods. So here we have used three methods: gated feature representation learning, Shapley value and the explanation model, and the Lime Shapley methods for the final prediction. This is the diagram for our proposed method. First, we have taken IDS dataset. We have taken three datasets, TON IoT datasets, BOT IoT datasets, and NSL KDD datasets. First, we have divided these datasets into number of shared layers, and we have extracted important features from the shared layers and which features provided to specific gated extractor to extract the information, meaningful information from the features. Then we have used three methods: global explanation model, local explanation model, and by using these two, we have done our Lime Shapley value analysis. So first, these specific gated extractor features goes to black box model. Here we have used CNN model for extracting the features, and then these values, then these features goes to global explanation and local explanation model, and out of this we have got our prediction. And for the test data, we have done our data to deep learning model. Then evaluation will have been done on the basis of three matrices: accuracy, precision, and recall. So our first model is gated feature representation learning. So this is gated shared layer architecture. We have used gated unit to remove the duplicate and incomplete information from the data. So the gated shared layer architecture refers to the neural network, which is designed to combine two key concepts, that is gating and shared layers. The utilization of this architecture is to serve the network learning and representation capacity through the application of gating mechanism and the shared utilization of layer across various segments of the network. So the gated mechanism is incorporated with the shared layer to remove invalid and duplicate information. So here, this formula is given that this is the output of LS layer. By giving the input of ith sample, it can be determined as follows. This is the weight value. This is the previous layer output value by adding LS layer of bias term. And we have used sigmoid function for this. Then each dedicated extractor obtain the extracted features from the final layer of the shared feature extractor. Then it extracts meaningful information to its designated target class, and the specific extractor acquire knowledge about their respective target class through the utilization of sigmoid function. So here probability is calculated by using this. Here this is the sigmoid function. This is the output of previous value, and by multiplying weight value and by adding bias term. Here, this is the probability of Jeff's target class, and the output weight matrix and the output bias vectors are denoted as W cap J and B cap J. Here, and here this finds our sigmoid function. And in order to tackle the issues of class imbalance, we have used each dedicated extractor by using binary focal loss function. Next is Shapley value and the explanation model. So basically, Shapley value is used as the game theory. It's come from the game theory concept. And the case of deep learning, these benefits align with the model prediction, and each participant represents the features in the input data. Shapley value offers a means to measure the individual feature's contribution to the prediction, and the significance of each feature is established by computing its Shapley values as follows by using this formula. Here, f of s represent the characteristics functions in the context of collaboration games, and n denotes the complete set of all available features, and this bsn is the functions for calculating important features from each Shapley value. Now we are combining live model with Shapley values, which offers comprehensive view of machine learning models interpretability, and live value provides specific insights by approximating the model's behavior near a data point, and it will explain the important region behind the prediction. Here, meanwhile, Shapley value provides a global perspective and as well as local perspective by using Shapley value. By merging, if we merge local Lime value with global Shapley value feature importance, these techniques bridge the gap between individual predictions and the broader model behavior. This integration is crucial for various applications, from debugging the model improvement and debugging the attacks and improvement to understanding biases and enhancing the complex deep learning system. The synergy of Lime and Shapley value provides a comprehensive solution for model interpretability, whether explaining the single prediction or unveiling the underlying attacks. Here we have used three important datasets: T1 IoT datasets, BOT IoT datasets, and NSL KDD datasets. In pre-processing part, we have used scikit-learn library for label encoder, and which converts the textual data into binary format. And we have it maintains the consistency in the training process. We applied a normalization procedure to all time-related features, and this will scale the features in the range 0 and 1. And these are the accuracy, precision, recall, and F1 score we got for binary class and for multi-class. For multi-class, we have taken 5 classes, and we have compared our methods with the state-of-the-art methods, and we can see our proposed methods give good accuracy compared to the state-of-the-art methods. These are the graphs of the classification performance matrices of IDS framework. These are the accuracy graph, these are the precision graph, recall graphs, and F1 score. This is here we can see this is the graph of our proposed methods. Here we can see our accuracy is good in compared to other methods. One results. This is the another results of on BOT IoT dataset. By combining these three terms, accuracy, precision, and recall. We have done class imbalance problem also by using this proposed approach, and here we have solved the problem of class imbalance. Here we can see our methods is good compared to another previous one methods, and here we have done this part by using NSL KDD dataset. So the conclusion of this work is we have provided a valuable tool for cybersecurity experts, which can improve the prediction of intrusion detection system. And Shapley value is employed to furnish the both local and global explanations for any deep learning based intrusion detection system. This means that it can not only can experts gain insights into the system regarding decision making, also they can compare overall behavior and performance of the system. So this is all about it. Thank you. These are the references of my paper. Thank you.
Yeah, good presentation. Thank you very much. I have few questions on this. You have done handcrafted features you have extracted, right?
Yes. I have expected some features like error control, like TCP ID number, ICMP ID number. These are the features I have expected by using Shapley value and line value.
Okay, and that you fed
And
into
ID of
CNN, right?
yes, sir.
Okay, so what is the size of the features? What is the
Sorry,
number
sir.
of features? How number of features?
Sir,
How many features?
965 around.
For one.
Yes, sir.
For a network,
For
965.
yes, sir, for NSL KDD dataset.
Okay, for KDD dataset. Okay.
And for
So,
another two datasets, there are few less number of features like 256 and 320.
okay. So, can you please go on your classification accuracy slide?
Okay, sir. Yes. Classification. This one, sir?
Earlier, this one. Yeah. So, many of the earlier researchers have reported good accuracy.
Yes, sir.
So,
But in our method, we are explaining the important characteristics of each features so that our system can detect attacks in a good manner.
okay. So, what will
On
be
the
the
basis of
novelty in your work?
novelty, basically, we have combined local and global features. In the earlier models,
Okay.
they have taken global features only, but we have taken local and global features both by using the Shapley and line value.
Okay, and in the parameter of accuracy, binary class, you reported 99.25. For multi-class, it is 91.55.
Yes.
Why a huge gap is there in 91, 99? Can you justify?
Sir, binary classification is simplest one, but during multi-class, there might be some more.
So, have you justified that? Means why it is going down so much?
Sir, I haven't justified in the paper, but I will
Okay,
think about it.
okay, fine. One more thing, you have talked about imbalancing problem, right?
Yes, sir.
Yeah. So how you have solved that imbalancing?
By using binary focal loss. We have used focal loss for this.
Okay. Okay. Fine. Thank you. Good one. Yeah. Over to you, sir.
Thank you, sir.
Can you go to the next slide, please, with the histograms?
Which one, sir? Just
The one after this one, with the histograms of recall and precision and everything.
okay. Just a minute. This one?
Please share your screen.
You haven't shared.
Okay. Sir, are you talking about this one?
Yeah, right. So, I mean, obviously, first of all, two things. This is more communication and clarity of presenting results. I mean, from the table, it's very clear that there's not a lot of difference between, I don't think any of these differences are significant between different various methods that you're comparing. But generally, accuracy, precision, and recall data should really be presented as line graphs, right? So you can also look at the area that's been explained, so to speak. And comparatively, I'm sure the lines will overlap, and therefore you seem to have done the histograms. So fine. I mean, that does not, it's an observation that does not undermine the effort you put into this research. but there's very little to choose between the different ones. You've already said what the advantages of yours to Dr. Patil's question. So I accept that. But the other follow-up question and the last thing you said in your conclusion was that your method, I mean, that partly is what also Dr. Patil was asking you about the difference between 99 and 91 between binary and more than two IoT models. The complexity will increase, right?
Yes, in case of multi-class.
Yeah, and computationally, then it becomes perhaps a really, I mean, I don't know, I can't do the maths in my head, but it may become an unfeasibly large computational effort such that the security advantages that you're claiming perhaps cannot be delivered from a practical point of view. What do you say?
Yes, there might be a chances in the case of computational complexity. I will look upon it.
Definitely, you should think more about that. I mean, maybe there is some way around that, but I strongly suspect. But obviously, we know. I mean, you know, network connectivities can be just exponential, and depending on the number of messages being sent between IoT devices, it can very quickly turn into an insurmountable problem.
Okay, sir.
Just my observation. I'm done. Thanks.
Thank you, sir.
Thank you. So next paper is 307.
Yes.
What's your name?
My name is Nivan. Could you please make Aditya Kulkarni, he's the co-author, he'll be presenting the slide. So could you make him the presenter?
Sure, no problem. Aditya?
Yeah. Aditya Kulkarni.
Yes, sir. I've raised my hand.
Yes. Okay, no problem. Now you are the presenter. Everything is fine. You may start.
Yes, okay. Can you see my screen?
Yes.
Yeah. Hi everyone. Very good afternoon to one and all present here. On behalf of all the co-authors.
Just a minute. Huh? Actually, I unmuted your. What's your name? Nivan.
Yeah.
Nivan. I need to make you the presenter also.
Sir, could you please make all the co-authors the presenters, because every one of us would be presenting some part of it.
Yeah, really? But
yes.
You need to complete your presentation in 12 minutes. Huh?
Yeah, we'll do that, sir.
So next one is Ayusa.
Pratik Ranka as well as Ayusha. Right.
Okay. What about Nilesh Patil?
He is actually our guide. So
okay, no
he's busy with lectures. Yeah, so he wouldn't be. Yeah. Okay. So hi everyone, a very good afternoon to one and all present here. On behalf of all the co-authors, firstly we would thank you all to give us this opportunity to present to you all our research work. We've been affiliated to DJ Sanghvi College of Engineering, all the co-authors. Our topic is cybersecurity threat detection using data GAN enhanced data augmentation. So just to start with the introduction, Adi, next slide, yeah. So just to start with the introduction, evaluating the global landscape, we've noticed two things, like the cybersecurity mechanisms have developed, but simultaneously the threats also have increased at a considerable pace, right? Even more requirements to develop good cybersecurity threat mechanisms. The traditional methods which are there in the cybersecurity threat detections, they basically like for multiple layers, like multiple types of attacks, like DDoS attacks, fingerprinting, etc. Because they are not viable because of the data set imbalance. So what our work does is basically we propose to you all three major things, like network. We classify the network traffic data into a visual representation. we synthesize this visual representation so that using the GAN enhanced data augmentation, and then we are having two levels of classification using advanced image classification techniques like DenseNet and ResNet. So the first layer is basically to detect whether the traffic instance is benign or malicious, and the second layer is determining what type of attack it would be if it is malicious. So that's the introduction. I would like to hand it over to Ayush to start with the literature review. Ayush, you can start with the literature.
Sorry for the technical difficulties. I'll continue on behalf of Ayush. So from our previous literature review that we have conducted, we noticed that many of these papers have worked on identifying multiple types of attacks, but they haven't been able to do it as with high precision and accuracy. Um, and they have used traditional methods, the traditional machine learning methods to classify and detect these attacks in various ubiquitous IoT systems. So what are the next slide, please? Uh, what we have proposed here in our work is that we have used a data set which contains around 76 features such as the protocol in the network traffic used, and we have processed this data, cleaning the data set and everything, and we have converted each and every network traffic instance into a visual representation of a 19 cross 4 black and white image. Using these images, we have proposed a GAN architecture to create fake images so that we can balance the data set. For example, in our data set, we had around 5,000 fingerprinting samples and around 25,000 DDoS attack samples. So to mitigate this bias and to create a balance in the data set, we used a GAN architecture to have proper balance across all types of attacks. So after having a data balance, we proposed a deep learning architecture using four models. So four deep image classification models: ResNet, DenseNet, VGG16, and Inception V3. So as you can see from the table here, we have the before and after sample classification, sample image count after we have performed the GAN enhancing augmentation. For our evaluation metrics, we have used F1, accuracy, precision, and recall, and various hyperparameter experimentations as well, which will be discussed in later slides. Yeah, so for the GAN experimentation, we took various hyperparameters such as the learning rate of the discriminators and the generators, the batch sizes of our data set, the number of epochs, and two important metrics which are FID and inception score. The FID basically illustrates how closely the generated or the fake images are closer to the real ones, and the inception score demonstrates that the images produced are of high diversity. So usually having a lower FID score, and a higher inception rate is a ideal scenario, and therefore we have considered the following given configuration for a GAN architecture. So from the results shown here, we can see on the left hand side, this is what we have created from the initial data set. We have around 50,000, 75,000, more than 75,000 samples for all of them for 19 cross 4 images, and a confusion matrix after multi-class classification for around 14 types of attacks. And we had an accuracy of around 96% for our binary classification and a 95% accuracy for our multi-class classification using convolutional techniques and image enhanced augmentation. And in conclusion, for what would be our future scope is that there are various attacks which are time variant as well. So we are trying to incorporate LSTMs as well as convolutional networks in our model architecture, so we can get access to the sequential data and make classifications on those bases as well. Um, yeah, so we are done and we are open to questions.
Any question from the audience? No question from audience.
Okay. So, good presentation, Pratik. And why you are chosen this computer vision based means whatever the network, why you have converted that to images?
Sir, like in traditional or current studies, what they have used is basically sequential arrays or network instances. But in some cases, in some research works previously conducted, they mentioned that it was computation. So converting these images, so we have taken, for now, we have taken 76 features only, and we have converted them into visual representation, black and white images. So processing black and white images via convolutional networks seemed much less computational, seemed computationally less expensive than processing numerical values in bulk. And we use deep learning architectures as well for this, so it greatly reduced our computational time, and we have generated good results as well with this. And this was something we haven't seen in computer vision cyber security threat detection system. So we wanted to, to go in a new direction and study new methods, so that we can get more we can propose new research work further ahead by other people.
Okay, so on images, machine learning algorithms are doing quite well. So why you went for deep learning?
Uh, Sir, deep learning makes training faster on large data sets. So we had quite a big data set, and we use this because we wanted to balance our data set first. Because as I mentioned, from the earlier data set from which we had created these images, for an example, fingerprinting attacks had only around 5,000 samples, and compared to DDoS attacks, which are around 25 to 30,000 samples. So using traditional machine learning techniques, we couldn't augment it as well. We can't augment images as well. So we opted for a GAN architecture first to augment these images and create a larger data set. And to train to train this large data set, we opted for deep learning architectures. So we use pre-trained models as well, and we added additional layers to them to suit it to our application and to a proposed model.
Okay, so have you experimented on machine learning, any classification algorithm?
No, sir, we haven't experimented on machine learning right now. We have only
Okay.
focused on deep learning.
Okay. Can you go to the slide where results are displayed? Earlier one. Previous one.
Previous one, Aditya, yeah.
Yeah, this one. Yeah. So these four models you are talking about, VGG, ResNet, and
Yeah, these are
exception.
pre-trained models, pre-trained deep learning models, which are usually used for convolutional and image and video data. So that is, we took these, we performed it with binary, and then on the next classification layer, we performed it on pre-trained, like the architecture itself, and then we added some layers on that to get a better view of what would happen.
Okay. So what is the reason you are getting less accuracy for VGG 16?
Sir, I am not quite sure, but this was just a comparative analysis. But as far as I know, VGG16 has a less number of pooling layers, a more number of pooling layers. So it reduces the dimensionality and it makes it more generic. So that might be one of the reasons we might be getting a lesser accuracy in VGG16. If we might be inculcating VGG19, we might get a better accuracy, but we haven't tried it with that yet.
Without converting that to the image, and then if we are going to detect the intrusion, you will get a better accuracy on these data sets. What do you think?
Sir, we haven't tried it yet, but our main focus was to make it less computationally expensive and make it and try a new avenue towards cyber security threat detection rather than just using the data received from the network or now.
Okay, fine. Thank you. Yes, over to you, sir.
No, I have no questions. It's a good paper. It's an interesting piece of work. Obviously, you want to explore further aspects of it in terms of whether the data you generate, the augmented data is, I mean, you've done some studies. What are the range for that? Because you say on that the data that you're generating, uh, you you were showing two matrices. One was like in single digits, and the other one was in 2 digits. So what's the range? What's the maximum you can have? Can you go to that slide, please? No. Yeah, no, this slide. The one
Aditya, the
before.
second slide of proposed methodology.
This one. Here, inception core, you said the higher the better.
Yeah,
I
so
understand.
this is a score which is majorly used for generative these GANs, but they determine what type the hyperparameters for which is ideal or optimal for our model. So FID basically indicates how the generated images or the fake images are closely related, like how similar are they to the
I
original.
understand. No, hang on. I understand that. So I assume for FID, the maximum is 100%, right? But the value for the inception score, what's the maximum value?
I think it's around 10. I think it's on a scale of 1 to 10.
Right. So and you need to give that. So that would sort of give one some idea. Because then if it's 1 to 10, then you're hovering around 0.5, right? So this is kind of well, random. It's probabilistically like goes either way. So I would need to see some scores there. And augmenting data, I mean, the problem with any kind of augmentation or creating data is if you start from existing data, it's very difficult, given the way computers work, to be really random about it, right? There's always random seeding that kind of is predictable to a certain extent, so the outcomes are kind of in a way explainable, right? You get nothing out of the ordinary. The earlier talk by Dr. Islam about quantum computing might give you the sense, the level of randomness that one desires but cannot expect from a von Neumann machine. But anyway, you can work on these things and see whether you can genuinely generate data that is kind of as real as possible and not constrained computationally in this manner.
Yeah.
Thank you, Ayush, Aditya, Pratik. Thank you.
Thank you, sir.
The next paper ID is the 217. Dr. Kaskula, I made you the presenter, so you can share your screen and start your presentation. Please. Please unmute your microphone, sir. Yes, now we can.
Yeah. Now you hear me, do you?
Yes, we can hear. Just share your screen.
Yes, so it is my first use of Microsoft Teams.
So near leave button, red leave button is there. Near to that, there is a share button. Using that share button, you can share your window screen.
Are you seeing something? No?
No.
No. Still not. So. Have you submitted your, just a minute, let me check. Okay, I have your presentation, so I can share your presentation. You just give it.
Now you are seeing it?
Yes, we can see. Okay, everything is fine now.
Okay. So thank you.
Just we have a little bit means next speaker is ready. So just try to complete in 10 minutes.
Yeah, okay. But just three quick notes to begin with. First, congratulations to colleague KK Patel for the organization of the conference. Okay.
Thank you, sir. Thank you.
Secondly, I present my compliments to the colleagues in India because India is a special country for us Portuguese, as you know, maybe better than I do. Third,
thank you. Yes.
The Portuguese Prime Minister, António Costa, is the son of an Indian from
really great
from Goa. By coincidence, and I am finishing that, what a coincidence, he was dismissed from the government yesterday. Okay. Okay, so 3 languages simulate polygons and perform on the web. I am a professor at the University of Lisbon, and okay, so on a web page, we display the statistical behavior of the perimeter and area of random polygons inscribed in a circle. The perimeter behaves surprisingly. 3 languages run at very different speeds, expected but notable, and the study is an example of the use of the web. This is an illustrative example adaptable to many other problems. And I invite any colleague, if he wishes to take advantage of this. It combines the web and suitable computer languages. Our main objective was to show the web as a computing medium, but the problem got its own life, became instructive on its own, and more broadly, we advocate the web both for scientific computing, because the executables are practically the same, and which we think neglected, the web should also be used in publications favoring the academia-industry link in our technological age. So, 3 small sections: computing over the web, the problem, and conclusion. And here I am in Portugal looking at India. Not very far.
In map.
Okay. On the World Wide Web, we find everything. Everything we wish, we can find it. And we find many calculations, but we, the authors, and many people, do not find many pages or for scientific computing, even in university web pages. So we are very special people, we the authors, and are there only 2 exceptions? One exception, a certain Professor Pons, whom I don't know, and he has a fine website. For instance, I know nothing about hydraulics, but let's look at one of his problems. Quickly. Okay, he has a lot of problems for his students, and we click. Oh, Of course, we gave no data. Okay, so now another exception, our own web pages. You just click and maybe you understand the things. Why don't the scientific articles supply a link for us readers to see or to use their findings? I am not accusing anyone, I am just complaining. Okay, so this is an example related. This is the page for our problem. Let's go on. You can click and go to my pages. So the problem. This is just an illustration. Let's go. So I made a million trials with random polygons of hexagons and got this result. These are the frequencies of the values of the perimeter and of the area. Okay, so now octagons. Okay, so the same sort of images, now with 10, with 20. Okay, so random polygons of 20 vertices are possibly almost equal to the circle where they are inscribed. But let's see now going down 6 vertices, now 5, now 4, and we got a surprise. Now there is a peak, and with 3, so the curve changes its style. Okay, so in theory, the polygons are defined, of course, by the coordinates of their vertices. These are just cosine and sine of then the angles are simulated by Monte Carlo and then sorted to avoid star polygons. The perimeter is obviously the sums of the sides, simple distances. The area might look very complicated to compute, but strangely, a formula from the 18th century shows that it is very simple to calculate it. Otherwise, this was then independently confirmed by Gauss. The procedure consists of simulating many polygons and make histograms for them. So, results. We provide the computational procedure to simulate random polygons inscribed in a circle, an application of the Monte Carlo method. Avoiding necessarily star polygons appears mathematically complex, so we resorted to, this is a particular case, sorting the vertices by their polar coordinates. The formulas are, for the perimeter, obvious, and for the area, after all, elementary. The computing runs in a public web page in PHP, calling Python, Fortran, and C with the GNU-plot graphing utility. It is on a Linux platform, etc. Sixth, the simulation runs on the server, so you have to install nothing, and your computer does not have to have a special power or matching operating system. The problem was meant just to be an illustrative example, yet it revealed itself surprise, showing a qualitative difference for the smaller number of vertices. So here are some examples. If we get random polygons, we have the risk, the big probability of being star polygons. And as I said, the more vertices you have, the closer the polygon becomes to a circle. If you want to play with my polygons, you can do it. So you can play with my polygons. And of course, if they are just random, you have sometimes star polygons. So everything I do, I offer to everybody. So conclusion. Of course, that's what I used to do with my students. A problem, but well, a problem in random polygons reveals some unexpected results. The problem tries to show how the web can be a medium for scientific computing. The architecture proposed serves many other problems in a simple style akin to areas such as engineering, informatics, mathematics, for which the inevitable difficulty is their intrinsic nature. Other languages can be used and, if mixed, if they are compatible through generous present-day standards, provided that speed, security, and licensing are adequate. The programs for the web can be essentially the same as if run on a local computer, lending themselves to previous building and debug. The scientific literature has, in our modest opinion, very much neglected the link to an associate web page. As we have verified in our academic and some industrial practice, web can be recommendable for both favoring the desirable academia industry link in our technological era for technology transfer also. So these are the two authors and some bibliography. You might criticize me. Why do you only refer yourself? Well, I have already complained that I feel a bit lonely in this immense planet. So, okay, thank you. That's all.
Thank you.
Is there any question from audience? Any question from audience? No, sir. Dr. Patil, if you have questions.
Yeah, I'm good. Thank you, sir. Yeah, I'm good.
Dr. Patel?
No, I mean, it makes a lot of sense, and I totally agree with the observation that the potential to present scientific results is part of an ongoing or a dynamic or a continuing sort of sense to that particular research is perhaps being neglected. I think we're still too wedded to this idea of reporting results in a publication format. So while it's a soft copy, it still remains a text, essentially. And
Yes.
I totally agree. But I don't see much hope either for people making that shift somehow. You know, we've had online publishing for 30 years now, and it's still the same as it was when I was a young man. So there you go.
Okay. Thank you.
Okay, sir, we are behind the schedule, so I'm in a little bit hurry. Thank you very much,
Yes.
Dr. Patil and Dr. Patel, for sparing your valuable time for chairing the session. Thank you very much, sir.
Thank you. Thank you.
Thank you very much
Oh,
for the invitation.
It's okay.
yeah,
Thank you.
and yeah, thank you. And I also want to appreciate, as others have, because I am associated with Charuset, the effort that Dr. Patel, KK Patel, and his team has put into organizing this, following up, reviewing papers, getting people involved, and finally, of course, what has happened over the last couple of days. So a great effort, and I hope we continue along these lines for many years to come, Dr. Patel.
Thank you. Thank you. Yes, sir.
Thank you very much, sir. Thank you.
So our next speaker is ready. So I would like to invite Dr. Chun for their invited talk. Dr. Chun, you are the yes, you can
Hello.
share your screen.
Hello, good afternoon. So yeah, good afternoon, sir. Are you able to hear me?
Yes, clear.
Good. Good afternoon. So give me a minute. Let me share my screen. Yep, the last time I went to India was back in 2019, before the pandemic. I've been to, I went to Ahmedabad University for 2 times. One in 2018, the other one is 2019. I've been to Hyderabad, Aligarh, Delhi. Yep. So India is a wonderful country to me.
Thank you.
Yep, just for your information. So recently, the Malaysian government has extended the free visa. That means the Indian nationality holding India passport. According to my understanding, you don't need a visa to come to Malaysia for holiday. So everyone, all my Indian friends, you're most welcome to come to Malaysia for holiday. Okay, so let me start my presentation. So if you can't hear me clearly, please let me know. My presentation probably, so I know the time, the organizer is behind the schedule. I try to finish everything in about 10 minutes time. So my topic is a little bit general. It is how we apply artificial intelligence in smart home systems. So AI is not new, smart home is not new. So basically, so it is a time to combine these two. So a little bit about Utah. So Utah, there are 2 campuses. This is a campus about 3 hours from Kuala Lumpur in Kampar. I'm based in the Kuala Lumpur city campus. So because it is a city campus, there are only 2 buildings. So all in, we have about 20,000 students. So okay. The presentation outline, I will basically talk about the smart home. After that, so how we put AI into smart home and some state of the art, the research in smart home and ambient assisted living. So smart home is not a new thing. Probably ever since maybe 1980s, 19, so probably has been there for about 30 years. It used to be for the rich people, but I believe now everyone, you don't need to be rich in order to have a smart home. Everyone can afford. So the latest trend, it is we call artificial intelligence smart home. And what will be the next? Probably after we put artificial intelligence into the smart home, probably it is a time to think about something we call assisted living, to assist especially the elderly in the activities of daily living. Traditional smart home, basically, I think this type of the system has been there for the past maybe 10 to 20 years. So this type of system, this type of the smart home system is quite common in Malaysia. So I believe probably it could be common. So in India as well. So this is what we call the traditional smart home. The moment you go home, you have to key in a PIN number. If you don't key the PIN number within 30 seconds or 1 minute, so the alarm, the siren, it will sound. Now, traditional alarm, the problem it is we can't access or control. We cannot access or control anytime. So we may not be able to, and we may not be able to do home automation in the traditional home alarm, so not integrated with the CCTV. Okay, the CCTV probably is getting more and more common. In Malaysia, I believe it's getting more and more common. So the CCTV anytime, anywhere. The traditional CCTV, is there artificial intelligence human detection? Probably no. So a lot of the CCTV system in Malaysia is still traditional. For example, there is someone trying to break into the house. So the traditional CCTV may not be able to detect that there is the human. Okay, yeah. Sorry for the Chinese character, because so I took some of the slides for my recent presentation to China. So some of the slides, so it is in Mandarin. I apologize for that. So AI in IP. So it is getting more and more common to put AI into IP camera now. IP camera is getting the cheaper and cheaper. So I believe a lot of the friends from India, you may have the IP camera at the home also. And the latest one, not every single IP camera, probably, for example, so I believe a lot of you may know Xiaomi, the brand from China. So one of the good thing about Xiaomi, it is the phone, the IP camera, it is affordable, and they have actually put in the human detection into the human detection into the IP camera. Yeah, the accuracy, it is acceptable, not very high, so there's still room of improvement for the AI algorithm in the Xiaomi camera. So they even have the facial recognition, for example. So if you want probably the affordable one, so you may have to go to probably for example, the Xiaomi brand from China, or the brand from the Europe, the US, they have got probably the person detection. But as you know, quite likely it will be much more expensive than the China one. So the Google Nest IP camera, they've got the human detection. They even have the vehicle, they have the animal. So as probably you know, the Google one, it is very expensive. So the D-Link one, they've got more. So the trend now is, okay, more and more smart home system, for example, the IP camera, we start to incorporate artificial intelligence into the smart home. So smart home, again, it is not new. We can do, for example, we can control the devices anytime, anywhere. But Malaysia, so I believe the same thing goes to India. So a lot of homes, so we have got the fiber to the home. So with the use of the fiber to the home, we can monitor the house condition. We can able to control and assess our house condition anytime, anywhere. We can do some home automation and the communication protocol in smart home. We can control the light. We can monitor the home energy management, the smart plug. So all these are not new. So basically, some of you, this is a motion sensor. So probably the friends from India may be more interested into the air quality detector. So I think so from my understanding is during the winter time, now it is a winter in India, the air quality in Delhi, so and the surrounding area may not be good at the moment. So the friends from India, you may need to have the air quality detector, so to monitor. So AI so this is a little bit new topic, AI in smart home. So AI in smart home, we can use the AI in, for example, activity recognition, especially the activities of the elderly. So just probably by the time we get old, so the one who take care of us, probably it may not be a human. So probably in 10 to 20 years time, the one who take care of the elderly quite likely will be the AI machine. So AI can be used in decision making. So it will assist you. For example, looks like you have left home, switch to away, and so this is AI will assist in a lot of the decision making. The AI will play a role in the video analytic. Voice recognition is not new. Okay, so the next one, it is to put AI into smart home system. AI in voice recognition is probably to me a little bit saturated. So, and the one which to me still have probably a lot of the potential, for example, how we apply AI in activity recognition, especially the healthcare related parameters for the elderly. AI in voice recognition, probably to me this research a little bit saturated. AI in video analytics, yep. So as you know, so everyone is talking about the how we apply AI in different aspects. So this one, video analytics, for example, the fall detection or the daily activities recognition, to me, so there are still there are still a lot of the potential in academic research as well as applied research. The other one, it is AI in decision and prediction making. Okay, one action to be taken. So next, so this one, a lot of the, as you can see, the based on this research, a lot of the product, the orange color, it is on voice recognition, a lot on image recognition, but not many product in prediction making, not many commercial product in activity recognition. There is still a gap. So quite a number of work has been done, the blue color in the activity recognition, but this has not put it to commercial products. So, and also prediction making. Prediction making, it is like, okay, the artificial intelligence smart home system will predict what we are going to do next. It is basically not for the young people like you and me. Probably it is to target in something we call assisted living. So how we use artificial intelligence, for example, the deep learning. So we analyze the data, we predict what the elderly will do, what the elderly will do next. So to me, yeah, so this work, this kind of we call ambient assisted living, there are still a lot of the maybe opportunity in academic research as well as the commercial. So growing elderly population, the shortage of the caregiver, the one who will probably take care of the elderly in the future, it may not be the near future, in 5 to 10 years time, the one who take care of the elderly, it is artificial intelligence. So by that time, our house will probably have a lot of the sensors, different types of the sensors, the motion sensor, the camera, to monitor the medication, to monitor the diet, whether or not there's a falling down. Is to keep people, elderly people, those probably 80 years old and above, they are connected, they are healthy, they are active, and they are happy into their old age. So I think, for example, you monitor the vital sign, environmental behavior. So I think all this time is running up. And this is some work I've done. I think the ambient assisted living, the fall detection, so done by my previous student. So more and more work in the fall detection, but the problem of the fall detection, it is how to collect the data set, because creating the data set for the fall detection is something maybe risky. You need someone to fall down, and the moment someone falling down, so it may cause some injury to the person. So the challenge of the fall detection, so it is how to create the data set, because we need the real people in falling down. Okay, so this is some of the thing. Yep, so that's it about my short presentation. Thank you so much for the wonderful opportunity for me to give a short sharing. So to every one of you, I pass the floor back to the chairperson.
Thank you, Dr. Chin. Thank you for sparing your valuable time for this talk. Any question from the audience? Anyone, if you have question, then else we are behind the schedule, so we can move to the next speaker.
Okay, so thank you so much, everyone. I have to make a move first. Thank you. Thank you for the opportunity.
Thank you, Dr. Chun.
Thank you very much.
So next we have Dr. Sonal Jain for its invited talk. So I welcome you, Dr. Jain, again on this icSoftComp 2023. And please, you can start your talk.
Sure. So my slides are visible?
Yes.
Yeah. So good afternoon, everybody. Glad to be part of this conference on a very second day. I was there in a very starting session, and now again back today. I could see that a lot of good invited talks and keynote addresses has been delivered. So I'd like to actually deliver my bit today. The title of my talk is Deep Learning Technologies for Identification of Dysgraphia, which is a learning disability. I would like to share a few points regarding it, that what is it, why it should be addressed, how did we initiated it, work done so far, and of course challenges and future directions for researchers, which may be helpful to early researchers or maybe the researchers who are working on this area, and if they wish, they could join us in solving this particular purpose. So learning disability is a neurological condition that affects a child's brain, and basically it impairs his ability to carry out one or more specific tasks. If a child struggles with a school or finds it difficult to understand some material, chances are that he or she is suffering from learning disability. Normally, these kids are tagged as a lazy or maybe mentally retarded or a slow kids, but actually they are not. They are suffering. They are neither suffering from lack of intelligence or motivation, but maybe they are suffering from a processing disorder which is related to a brain. What causes this learning disability? Exactly, there is no one common factor which causes learning disability in a child. It may be inherited. A child with a learning disability most likely has a parent or maybe ancestor who has displayed difficulties with learning skills but was not yet diagnosed. LD may also be associated with a impaired brain development during either pre-birth or maybe post-birth. Premature birth, infection, oxygen deprivation, or exposing the fetus to drugs or alcohol may be one of the reasons, or maybe after birth causes like physical injury later on in a head region, particularly improper nutrition or exposure to toxic substances, or can also interfere with a normal brain development. There are multiple learning disabilities which do exist in a literature, which doctors also agree, and there is a lot of good literature available on this, and it can be categorized into dyslexia, which probably many of us have heard about it, ADHD, dyscalculia, dysgraphia, and dysgraphia. Dyslexia was quite made popular by movie Tare Zameen Pe, and many of us then actually started thinking about, yes, this kind of things also do exist. My focus or our work's focus is on dysgraphia. This is also one of the learning disability, and also actually I would like to share that these morbidities do coexist. So it is not that one is suffering from dyslexia, that person may not have a dysgraphia, and vice versa. But it is quite difficult to actually analyze the symptoms of these kinds of diseases and later on actually treat them. Current scenario is actually alarming, which says that incidence of dyslexia in Indian primary school has been reported to 2 to 18%, dysgraphia 14%, and dyscalculia approximately 6%. We have 90 million people with varying degrees of learning disability today, with average class in school, and every average class in a school has about 5 students with LD. Nimhans actually did a study where total prevalence rate of SLD is 12%, particularly written difficulties in written expression is 8 to 15%, and 6% of the school population has mathematical difficulties. In general, this is the reported ones, but 2% of the students are detected by grade 2, and 40% by the age of class 12. Around 55 to 60% are never detected. Most of the teachers and parents are not aware about the learning disabilities among the children, and basically it causes children face difficulties at a later stage. Even I actually, being in a higher education, actually came to know during my tenure as a head of the department, where I actually received applications where actually they shared with me that they have these kind of learning disabilities, and some extra time is required in examination, or maybe actually some liberties are required in examinations, which are actually government recognized liberties. So particularly dysgraphia, what we are talking about, it refers to the difficulty with the physical act of writing. It basically includes cramped grip while holding a pencil, illegible handwriting, inconsistent spacing, poor spelling, unfinished words or missing words or letters. Child may also have a trouble in reproducing the shape of a letter or drawing. Having dysgraphia can also make it difficult to think and write at the same time. While writing a story or some articles, the child may start, or maybe with single paragraph, the child would start in the middle or leave out important facts and details, or maybe the child would repeat same point over and over unknowingly. Dysgraphia also includes actually writing with lot of grammar and punctuation issues. These are not normal issues we each one of us do actually regularly make, but repeated issues of the grammar and punctuation, not starting letters with a capital multiple times. Actually, even after given warnings, they won't actually write letters, proper nouns in a capitalization, and they would forget basically these things. And writing sentences basically that run on forever, they would forget to write punctuations like full stop, comma, etc. These are the samples of handwritings in English language, particularly for dysgraphic kids, which are actually availed from various sources of internet and neurologists. These are the correct list of the, I would say that apt list of the symptoms which actually students with who are suffering from dysgraphia do face. As I mentioned, like difficulty in writing the letters down and properly spacing the form characters. In Indian scenario, we do actually make students write, if Hindi or Gujarati, then we ask them to write in a 2-line notebooks, or maybe actually if it is English, it's a 4-line notebook, and if it is mathematics, then actually square notebooks. But at times these kids find difficulty to actually arrange their letters initially on these kind of lines. We may tell them that actually write down in a 4-line properly multiple times, but they won't be able to do it because thinking and writing is actually a problem for them. So this is what actually dysgraphia is, and we at times tag them as lack of motivated kids. So current situation is lack of awareness about it among parents and teachers, and easy way of knowing if a child may have dysgraphia or not. That is, how do actually a person concludes that their child is at a risk of dysgraphia. So solution is a scalable system that can detect dysgraphia, and given handwritten images of a person, the system should be able to determine whether the person is at a risk of dysgraphia or not. So this is the impression of the project on which we are working upon, which I am sharing during this invited talk, that we have actually proposed, in fact, developed a mobile application where handwritten images of a kid can be uploaded through a mobile app, and we have developed certain deep learning neural networks which can classify that whether the kid is at a risk of dysgraphia. We do not dictate or tag that kid as a dysgraphia. We just actually identify that there is a risk of dysgraphia. So actually proper consultation or clinical psychologists or maybe actually neurosurgeons or counselors may be contacted. The pathway chosen for doing this, we are working on this area since 2 years, and pathway chosen by us is we started with conducting awareness seminars. We targeted schools of Jaipur and Rajasthan. We did develop a new data set of handwriting text images, which I'll be talking for here for a few minutes, because I would like, if people are interested, we can share this handwriting data set with them as well, and they can also get involved with us in developing algorithms. And we have also, as I said, initiated developing an automated early detection model. Input is handwritten text images and algorithms are deep learning algorithms. These are some snapshots of creating awareness sessions, and these are the data collection screenshots. I particularly would like to showcase it over here because as I said, we are open to sharing data sets as well. Data sets are collected in two means. One is actually they have written it on paper, and second is we also did purchase Wacom tablets, and we did share it with the school students wherein they have actually written or given us the data through Wacom tablets. And I'll showcase later on that what features of Wacom tablet actually helped us to further collect features particular with respect to each and every handwritten images. We collected data using two activities. One is think and write, and second is see and write. All these activities were designed in consultation with clinical psychologists because they are experts of that. We being belonging to computer science discipline had to actually talk to them multiple times that actually finally during what kind of settings we should actually collect this samples and what would be more helpful to us. So we actually gave class 1 to 3 certain topics like my father, my teacher, my mother, my dream home. Class 4 to 5, my school, my best friend, my birthday party kind of topics were given. For class 6 and 7, health and fitness, pollution, importance of traffic rules were shared, and they had to think and write around approximately 10 to 20 lines, and of course within time duration of 10 minutes. We assume that each kid was having similar kind of knowledge as they belong to same class. And second activity was writing from the board, that seeing and writing whether they are able to do it both the things properly or not. A sentence was quick brown fox jumps over the lazy dog. Everyone of us are aware that this consists of this statement basically consists of all the alphabets, and the dog had got angry and bit the fox 1 2 3 4 5 6 7 till 10 times. So all the numbers were also covered, and the student was expected to write it twice. We were able to collect these kind of data samples. Right side actually it is a creative writing, on the left side it is copy and write. We do have currently a data set of 2400 non-dysgraphic and 111 samples of dysgraphia. However, there was challenge of collecting samples of dysgraphic kids. We did collect it from an open source, like a few blogs were available. Few actually kids do shared with us these samples, although they were not, everyone was not readily agreeing, but still actually we could manage 111 samples of dysgraphic kids. We have divided this data set into the ratio of 60 20 20, where 60 is used for training. So approximately 1867 images are for training, 321 images for testing, and 323 for validation. Deliberately, this 111 has been divided into 3 sets because we were not having enough dysgraphic images. We could not opt for a random sampling, but we have manually actually distributed it into 3, that is 51 into training, 30 into testing, and 30 into validation set. Of course, pre-processing was quite an important step for us. So we normalized the data. We actually used bilateral filtering and thresholding and converted the images to grayscales. Important for us was gathering the active regions or the regions which aware of our interest for further processing. For that, we used efficient and accurate algorithm that which crops an image basically. However, that image actually crops words or sentences, but we wanted an entire region, so we had to modify it, and we have utilized modified yeast algorithm. We also used a data augmentation technique to increase our data samples. However, we could not succeed to increase them beyond a certain point, else it was creating a noise. So we actually restricted ourselves to only 3 things, that is zoom range, only to a range of with a range of 0.1, and shift width range and width shift and height shift. That also to a very nominal value of 0.1. This is a taxonomy which is related with the entire work. And if you can see, although in the right side, there are certain traditional algorithms which has been utilized in a literature by various resources. What important to us is the digital features and hardware features, that on what features basically we can identify that whether the person is at a risk of dysgraphia or not, given a handwritten image. So baseline angle, whether the person is able to write on the same line, all the words were on a almost on approximately on the same line. We are not saying that very good handwriting should be there. Normal person also, even we actually always say that doctors do not write, their handwritings are not good. So, but they have certain characteristics in their handwriting that they write in a same line or maybe actually slant angle, that it doesn't happen that some letters are quite slanting and some letters are not. These dysgraphic kids actually tend to write some letters slanting in the left, some in the right. So the inappropriate behavior is being observed. Spelling errors, quite a lot spelling errors. Average letter size actually quite varies. And line spacing, this is one of the most actually problem within them. We say that keep 1 finger distance between 2 words, but these people, these kids actually hardly are able to do it. And as I said, why did we use Wacom tablet? That was for capturing hardware features which we were not able to capture through this digital image. That is writing speed, pen pressure, time, pen grip, and acceleration. That is timing. Although actually all 2400 samples are not collected using Wacom tablets, because in real life scenarios when we went there, capturing data through Wacom tablets of all the students and all the activities was actually not feasible. Sharing about machine learning and deep learning algorithms, we had worked on 6 variations. That is, we started with handcrafted features and application of one class SVM, CNN. We have modified CNN as well. And we also used pre-trained network. GLCM features, which is gray level co-occurrence matrix, which works on a texture. VIT, that is vision transformer, which is based on a transformer models, which is quite popular for natural language processing. And there's a paper called Image is Worth 16 by 16 words, which is now quite popular, and many people have started applying it, transformer models on images based on that paper. A hybrid approach, of course, actually was preferred because of certain differences, which I would be sharing within few minutes. And at the end, we preferred ensemble approach. So this was actually, this is a flow of a working with a handcrafted features. My last slide, where I would also share certain challenges we have faced in this. We actually tried to, as I shared before few minutes, that we tried to extract certain features like baseline angle, pressure, slant angle, letter size, line spacing, word spacing, spelling errors, and irregular capitalization. We have written algorithms for this, but although the challenges lies in each and every algorithm, because we were struggling with getting good OCRs. We tried with simple machine learning methods. I would not say simple, but traditional machine learning methods like logistic regression, SVM, random forest, which actually gives pretty good results in many other areas. But to us, actually, we were not quite happy with that. And we came across one class SVM, which is normally used in anomaly detections, where actually, or outlier detections, where if few samples are deviating from the regular ones, then actually one class SVM performs quite better. And and literally actually it performed very better, quite better, and time complexity was quite less as compared to other algorithms. But we could not actually carry on further with this one class SVM, and we had to go for ensembling because we were struggling with these kind extraction of these features, and one class SVM was based on these features like baseline angle, pressure, slant angle, spelling errors, and so on. Pre-trained networks which we have explored are VGGNet, 16 and 19 both, RESTnet, InceptionNet, and MobileNet. The results are on the screen, where VGGNet actually outperformed with 91.87, and InceptionNet also actually gave us good result like 92. Residual net, of course, 93, and MobileNet actually could not deliver us good result, 72%. But what point of observation was there, that if there is no risk of dysgraphia, we do get good results. But during like as far as validation set is concerned, risk of dysgraphia was not actually at par. The result which was expected, which we could not actually get when it comes to extraction of dysgraphia. Then we actually went for exploring CNN, modified CNN. We used a hyperband for parameter tuning. We used 4 convolution layers with max pooling, with a dropout layer to avoid overfitting. This is an architecture of it, and this is a summary of that particular model. And we could receive good accuracy of 94, but again, actually, when it came to the risk of dysgraphia, it was 87.63. Although I won't say that it was too bad, but still, actually, we wanted to improve this particular risk of dysgraphia. Third was GLCM. Our handwritten images actually had certain images which these people, basically these kids, actually tend to write with a different, I would say, pressure. At times, actually, while writing, initially they would start with a good pressure, so their handwriting would be darkened. But as far as after writing 1 or 2 lines, their grip would be loosened, and their words would be of like gray in color, that is lighter in the color than what they started. At times, it also happens that some words in between are darkened, some words in between are light. So actually, we thought the texture-based algorithm would actually give us good result. And we could explore good features based on GLCM algorithm. Then we did try Vision Transformer. Vision Transformer actually divides the image into multiple patches, 16 by 16, as mentioned in this particular paper. And we did use encoder for this. And finally, actually, this model could give us good result with 95%. And benefit of using this VIT was it was quite faster in convergence, unlike other algorithms. So it was, while extracting features, actually it was quite I would say, with respect to time. With respect to quality, we had to go for ensembling, because again it was we were not too much confident when we experimented with validation dataset. Then we thought of exploring an hybrid approach, where actually feature extraction, handcrafted features, then features using GLCM, which were dissimilarity, correlation, homogeneity, energy, contrast, basically texture based features. We had handcrafted features, and Vision Transformer features were also with us. So we did actually made a combination of all these features, and then actually we utilized feature fusion, and later on we applied all 4 algorithms like decision trees, random forest, logistic regression, and SVM classifier. So in this approach, our accuracy, of course, actually increased, because it was a fusion of multiple features. So 97% accuracy has been achieved again, but as I keep on saying again and again, when experimented with validation test, again at times it gives 97 accuracy, but while supplying foreign image which is not available in the data set, it at times actually gives us incorrect results. So we are still experimenting it further. Ensembling approach, of course, we had to opt for, because each one was giving us different variations of the output. So GLCM, VIT, CNN, one class, SVM, and hybrid. And finally, we utilized majority voting technique for giving results to end user. we have our prototype ready with us. So if anyone of is interested later on, actually can connect with us. This is a mobile application, but yet we have not uploaded it on a Play Store, but it is already ready. Very nice. Person can actually upload an image and then can get the risk of dysgraphia with a certain percentage of a confidence. There is a demo of mobile app and website, but looking to the time, actually, I won't demonstrate it right now. But this is the right side. This is a website, and left side, this is a mobile application where we have uploaded learning tutorials, which to make people aware about this kind of learning disability. And also, we have section called a contribute, wherein if people want to contribute handwritten samples, or if they are aware about some kids who have already suffered from this and if they are having certain certificates or something like that, and if they would like to contribute their own handwriting samples for a research, there is a section called contribute, and we do promise that we would keep data anonymous. So at the end, I would like to conclude my session with that what kind of challenges we have faced during these 2 years, and we are still in continuation with this work. First one is data collection. Second is privacy issues, because social stigma is associated with learning disorders. People do not want to allow to discuss, even if we are aware that their kids are having this kind of issues through one or other sources, but the parents do not want to discuss this issue openly. Neither schools are allowed to discuss these things openly. So we, at the end, we have dysgraphic samples we do lack dysgraphic samples. Image balancing techniques, we did explore multiple one, but still we are looking for a good image balancing techniques. For new numbers, SWOT technique is working quite better, but for image balancing techniques, we are still struggling. Perfect OCR for working on semantic features, because we would like to find out spelling errors. We would like to find out whether same word has been mistakenly written in a different way in a same paragraph. If maybe actually beautiful word is coming 5 times in the same paragraph, that kid would tend to write twice correct, and 3 times that person would write incorrect. So actually, to see these mismatches, we want the perfect OCR. Dependency of hardware we would like to avoid. As I said, we have utilized spatiotemporal features as well, but in a real life scenario, it is not possible to take handwriting samples on these kind of tablets. Further improvement in models is of course expected. Reduction in time complexity. We have already integrated this models in mobile, but still actually even after uploading it on a cloud, it takes little bit of time. So there is scope of reduction in time complexity, specifically when doing ensembling, it takes quite large time. Study of samples of a same individual in a different context needs to be collected. And yet we would be experimenting, or if somebody is interested, can experiment on whether same techniques can be applied for multiple languages, because it may happen that a kid is doing good in a first language, but in a second language which is not his first language, which is not speaking or writing regularly, is finding difficult. That maybe actually English is not our first language, so at times actually it happens that people struggle in a second language. So these are the challenges which I would like to conclude my presentation with. And my team actually includes Dr. Basant Agrawal from Central University of Rajasthan. He is a PI of this project. And we have a team of clinical psychologists who are doctorates in their own fields with us. These are certain references. And thank you so much for listening to me. My email ID is sonaljan@spuvvn.edu, and I request you to visit our website, that is tild.co.in. Open to questions.
Any questions from the audience? It was really nice presentation. Yes, any question?
I'd like to, I mean, it's not really a question, it's more an observation.
Sure.
I understand the difficulties you're talking about in terms of, finding it tough to be able to write properly and all the other things that you said. But there was a time when to teach how to learn to write, I'm sure you've come across this question before, where it was just, guti a kind of thing. You just kind of did it, right? By And I mean, is that not effective? Are there some disabilities where it is not effective at all?
No, sir. Actually, after even multiple trials, that kid would fail if actually he is having brain disorder. Means actually hand, there's a gap between coordination of brain and hand. So signals actually, these two things should work in coordination, which is lacking.
No. So that matters. But then, what was partly the question was because right at the very end, you said that another example of this kind of variation in this disability was the second language, or whether it was your native language or not. And I mean, then why would the brain and the discoordination between the brain and the motor movements,
No,
why
that
would that
was
be
with,
more effective?
so that was with respect to whether same deep learning models would be applicable in other languages. I was talking with respect to that.
Okay. Yes, I understand. Thank you. Well, very good. Good research. I really like what you're doing. Carry on, please. It's
Thank you so much.
rightly, meticulously thought out research work and very well done. Very well, very scientifically proper.
Thank
Good
you
luck.
so much for your input, sir.
Thank you, Dr. Jain, for giving this very interesting and very informative and thought-provoking talk to us. Thank you very much, Dr. Jain. I have many questions, but I will write you through email because
You're
we are
welcome, sir.
behind the schedule.
Yep.
So we'll move to the next technical session, that is S8. And the session chair is Dr. Sailesh Iyer. So I welcome you, Dr. Iyer, for this session S5, S8. And I hand over the session to you. Please, in this session, we have 5 papers to present.
Okay. Very good afternoon to all the authors. We can start with the session, sir. Any instructions? I think so. They already are aware about the instructions.
I already circulated with them, but we can give 10 to 12 minutes to present that talk or to present that paper. And then we have 2-3 minutes for the question.
Fine, sir. We can start with the presentation. I would like the presentation to be very compact and to the point so that we can complete it by the time duration that we have given the slot for that.
Right. So is author of paper ID 211 present? Anuja, are you there?
Sir, this is Anuja. Yes, sir, I'm here,
Okay.
sir. Sir, one doubt. Will you be sharing the PPT, sir? Because the share,
yes,
yeah, it's enabled announcement. It is enabled.
I made you the presenter so that you can share your PPT. If you have.
Okay, sir, I'll share it. Sir, is my screen visible to all of you?
Give me a few minutes, few seconds.
Yes, visible, yeah.
Okay.
Is it visible?
Good afternoon, everyone.
Because I cannot see it. Is it visible?
Sir, is it visible?
Actually, I don't see your presentation. Dr. Iyer, is it visible to you?
It's visible, but it's stationary. I mean, there is no movement. So,
yeah, I have not moved, sir. I have not moved anything. Okay, I'll start the presentation.
Okay, no
good
problem.
afternoon, respected chairs. Myself is Anuja. I'm from Deva University. The title for my today's presentation is Blockchain Segmentation, an Industrial Solution for Large-Scale Data.
We can see your screen, but we can.
These are the contents that I will be presenting for today's presentation. We begin with the abstract, problem formulation, the results obtained, and the conclusion. Coming to the abstract.
Can you share it again?
Yes, sir.
Can you share the screen again because we are not able to view your PPT?
Yes. Please share your screen again. Yes, now it's visible.
Is it visible now, sir?
Yes.
Okay,
It's
thank
visible.
you, sir.
Okay, you may continue.
Yes, sir. Coming to the abstract, the presentation deals with the blockchain technology. As we all aware, blockchain is an advanced technology wherein we will be transmitting the data. So in a blockchain technology, an automated digital ledger, or which we call it as a distributed ledger technology or DLT, it is used to securely transfer the data across the different networks in a decentralized manner. So advantage of DLT technology is that it can record all the transactions and all the details can be recorded and the data can be transmitted across the different networks. So in this presentation, we propose a new idea of a segmented blockchain in which instead of transmitting the entire segments, we divide the segments into we divide the entire data into smaller segments and we transmit each of the segments over the entire blockchain. So the advantage is we can reduce the storage requirements. Coming to the introduction, if we transfer the entire blockchain, the general size of a blockchain segment varies from 15 GB to around 1 GB, 1 MB per hour. So if we divide this into multiple segments or multiple blocks, we can save a lot of memory and even the communication speed can also be increased. But we need to ensure that this process guarantees the integrity and the immutability of the transaction data. So coming to the literature survey, we have referred a few papers which are dealing with the blockchain technologies. The first paper is a blockchain pruning technology wherein in pruning they remove all the unwanted data that is available in the blockchain. In case of a sharding technique, we divide the blockchain into smaller segments so that the data can be transmitted in parallel. In case of a weighted model, each of the node will be associated with its own weight, and the nodes which are having a light weight will form a light-weighted system, and they will not be storing the block as such. In case of a peer-to-peer model, the data is transmitted among the networks by ensuring the encryption and all the sufficient cryptography methods. So the blockchain segmentation problem is stated as the aim is to implement a segmented blockchain model to reduce the storage requirements without compromising the security. So in this technique, we have used AES algorithm, which is a symmetric encryption algorithm, and we have used a MapReduce technique and logical block addressing. So coming to the techniques what we have used for cryptographic purpose, we have used AES, which is an advanced encryption standard algorithm. It is a symmetric key algorithm wherein the same key is used for encryption and decryption. The size of the block is, or the key size is 128 bits. And for hashing, we use MD5 as the hashing algorithm. And again, once if the data is there or if the input is there, we go for the concept of a MapReduce concept. In a MapReduce concept, the input is divided into multiple portions, and each of these individual systems will be processing the data in parallel. And in the reducer phase, the data will be sorted and the result will be obtained as a combined result. Now coming to this logical block addressing. Logical block addressing is a MapReduce method in which we use the logical address of the block rather than the. So whenever we divide the data into multiple segments, each of these blocks will be assigned with a logical block addressing, and these addresses will be used for the file uploading and for the file downloading purpose. So here the diagram represents the file uploading process. So in case of a file uploading process, the user will select the file. The blocks are divided. Each of these are the logical blocks and each block is assigned with a logical address. The hash code of the MD5 AES algorithm is used and the hash code is generated and the data is uploaded. In the file downloading process, again the user will select the file. Select the file will be taken based on the logical block addressing. The data will be retrieved and the integrity of the data is checked and the file is downloaded. So in the evaluation process, when we can see that have considered a set of 30 files. And if you do this process without using a MapReduce format, the total number of blocks that is obtained is 850. But if you use this MapReduce process based on the logical block addressing, and we can even verify the integrity of each of the block, and the repeated blocks can be avoided, then in that case, we can achieve the process with a maximum of 415 blocks, wherein the total number of blocks can be reduced to almost half of the size. This will increase the transmission speed, and by using cryptographic techniques, we can ensure that the proposed method secures the data. So we can conclude that in a blockchain technology, a digital ledger is used, and cryptographic algorithms are used, and the data is distributed among the different networks by ensuring the security, and the number of blocks are reduced, and the overall cost associated with running and maintaining the entire blockchain system can be reduced in this way. That's all, sir, about the presentation. Sir, can you hear me?
Yes. Any question from the audience? No question. So, Dr. Iyer, if you would like to ask any question.
Yeah. So, like from a user point of view, what is the novelty of the work that you have shown here right now? You can just justify in a few sentences.
Yes, sir. Okay. Yes, sir. If I talk about the novelty, the system as such does not provide any novelty. Why? Because we already know MapReduce is an existing technique, and segmentation or the blockchain is also available in the network, and MD5 hashing function is also available, and AES is also available in a cryptographic network. But in our case, we are trying to integrate all these three different components together to provide some advantage in case of segmentation.
Yeah. What are the future work that you propose to do in this domain, which can help you to take this research forward?
Yeah, sir, actually as such, because I work as a faculty and this is my student's MTech project. So we have not decided much about this, but the next thing is if the blockchain technique can be applied with the segmentation and cryptography to a healthcare sector, it can help the community to transfer the data and to avoid all the redundant set of data.
Okay, fine. I think so. It was a nice presentation. I hope the audience
Thank
is not
you, sir.
an Fine. We can move on to the next paper, sir.
Okay, so next paper is 214, and I think Jyoti.
Thank you, sir.
Thank you. Jyoti, you are the presenter, so you can share your screen.
Yes, sir. I will share, sir.
Oh, sir.
My screen is visible.
Yes, it is visible. Just run the presentation.
Okay, just one moment.
Make it full screen, yeah.
Turn to presentation.
Okay,
Yes, everything is fine.
Yeah. Good afternoon to one and all. Myself, Dr. Jyoti Prasanna Patra, and I'm working as associate professor in the Department of ECE at Vidyajyoti Institute of Technology, Hyderabad. So today my presentation is on iterative interference cancellation for STBC FDM system over doubly selective channel. So these are the outlines of my presentation: introduction, STBC FDM system model, then OFDF signal detection method, then the proposed iterative interference cancellation method, simulation results, conclusions, and references. So first of all, the introduction. So recently, almost all wireless communication demands high link reliability and high data rate without sacrificing extra power and bandwidth. So STBC, that is space-time block code, which was proposed by Alamut in 1998. So it was providing very high link reliability, but it is limited to flat padding channel. However, in practical scenario, the channel is both frequency selective as well as time selective rather than flat padding. So the frequency selective problem can be solved by applying OFDM techniques, as OFDM converts the frequency selective channel into many narrow parallel flat feeding channel. So STBC OFDM can achieve very high reliability without increasing high power and bandwidth. However, in time varying fast feeding channel, the STBC OFDM suffers from two types of interference, namely co-channel interference and inter-carrier interference. So, co-channel interference arises because two consecutive OFDM symbol blocks are coupled with each other at the receiver side, and ICI occurs due to the loss of orthogonality among OFDM subcarriers due to time varying channel. To obtain original transmitted signals, several signal detection methods are already proposed to suppress the CCI and ICI effects, like diagonal zero forcing detection method, successive interference cancellation, decision feedback detection, order iterative decision feedback, maximum likelihood, sequential decision feedback, sequence estimations, and time domain block linear filter. So in this work, we have proposed iterative joint CCI and ICI effect to suppress both the CCI and ICI effect. So these methods are DZFD, PIC, DZFD, where DZFD is diagonal zero forcing parallel detection, diagonal zero forcing detection with parallel interference cancellation, DZFD. Similarly, OIDF, order iterative decision feedback, OIDF, PIC, DZFD, and OIDF, PIC, OIDF. And we have compared our proposed method with all the conventional methods in terms of symbol error rate and computational complexity. So first coming to the block diagram of STBC OFDM system model. So a random data sequence is generated and then mapped into either BPSK, QPSK system QAM. Then it is passed to the STBC encoder, and after and then it is transmitted, it is passed through IF50, and after addition of cyclic prefix passed through the channel, and at the receiver end, after first of all we will remove the cyclic prefix and then perform the F50 operation. After that we will do the STBC decoding and we will get the original transmitted signals. So if we go to that at the transmitter side, as I already discussed, a random data sequence is generated, modulated, and encoded according to Alamouti scheme. So we have transmitted X1, X2 in the first time slot from two transmitting antenna. Here we have two transmitting antenna and one single receiving antenna. So X1, X2 are transmitted from the two transmitting antenna, and then in the second time slot, minus X2 conjugate and X1 conjugate are transmitted. And then this here in equation 1, where k is the kth subcarrier, where k varies from 0 to n-1, that means OFDM has n number of subcarriers. Then that is STBC encoded signals are OFDM modulated using IF50, and after insertion of cyclic prefix are transmitted through the channel. And at the receiver end, first we will remove the cyclic prefix and then perform the F50 operation. So we'll see that y is equal to hx plus I into I plus w, where h, so hx, so this is my desired diversity, and then this is the ICI. Inter-carrier interference. Here we'll see that k is equal to m, that is diagonal elements and responsibility for desired signal, whereas k is not equal to m, that is that turns to ICI, inter-carrier interference. So for sufficient large number of subcarriers, the ICI effect can be initially ignored and can be modeled using wide Gaussian process. So we can write as Ik plus Wk, that is equal to Vk. So Yk is equal to h of k, x of k plus Vk, and here we are talking about kth subcarriers, and k varies from 0 to n-1. And the Alamo detection is performed by multiplying h Hermitian into y. So we'll get as G is equal to h Hermitian h. So it is not a diagonal matrix. So we'll get as rho 1, rho 2 are the diversity gain terms, and beta conjugate are the CCI terms. Then several CCI signal detection methods are proposed: DMLD, diagonalized maximum likelihood detection, and then zero forcing decision feedback, ML, SIC successive interference cancellation, then least SIC method, then diagonalized zero forcing detection method, which is achieving the same as DMLD with very less complexity, and then OIDF, order iterative decision feedback detection method. And out of this OIDF method, achieves similar to ML, that is optimal, and with very less computational complexity. So first of all, we'll discuss about CCI because it is a joint CCI and ICI cancellation method. So actually, the proposed method consists of 3 stages. The first one is CCI signal detection method. Will obtain the rough estimate of the signals. So here we are applying for CCI signal detection method. We are applying order iterative decision feedback, which is a hybrid technique of diagonal edge reinforcing detection method and SIC with iterations. So as we know that H Hermitian H is not a diagonal matrix, so we are multiplying a omega matrix and it will gives me a diagonal matrix which is diversity. So here after solving omega, we will get the channel frequency response matrix as in given in 7. And the value of phi, that is the diversity, we will get as in equation 8. And so we'll get the estimated transmitted signals as in equation 9. So this is the diagonal edge reinforcing detection method, and this is the initial stage of order iterative decision feedback method. So here we have so OIDF method is summarized as below. So first of all, we'll perform the alarm detection method, that is H Hermitian into Y, and we will see that in 10 where rho1 x1 is the desired signals and beta k and x2k, this is the CCI signal. So if rho1 is greater than rho2, then we will set variable a is equal to 1 and b is equal to 2. Otherwise, we will set a is equal to 2 and b is equal to 1. So temporarily, so first of all, we will apply the DZFD, obtain the rough estimate signals, and then cancel the contribution of the CCI will to get the desired signals in an iterative manner. And we will see in the simulation results that only 2 iteration is sufficient for OIDF method. And then so all these signal detection methods like SIC, DZFD, list SIC, alarm out, all these signal detection methods are focusing on only CCI, but still ICI is present in the signal. So initially we are ignoring the ICI effect, and now we'll have both the ICI effect also we are taking into account. So we have proposed the 3 iterative joint CCI and ICI signal method like DZFD, PIC, DZFD, OIDF, PIC, DZFD, OIDF, PIC, DF. So it is a 3-stage process. In the first stage, CCI signal first of all, we'll perform the CCI signal detection method in order to obtain the raw signals, and then with that signals we'll estimate the ICI and subtracted it, and now we'll get an ICI free signals, and then again we are applying the CCI signal detection method in an iterative manner in order to get the refined data signals. So this is the block diagram of the proposed signal detection method. So first of all, so 3 methods are there. So the first method is DZFD, PIC, DZFD. So this method estimates the transmitted signal using 3 stages. In the first stage.
Sorry for interrupting you, Jyoti. Please try to complete in 3 minutes.
So give me 7 minutes. I'll complete.
It's okay, no problem. Just because we are behind the city, no problem.
So we have scheduled. We have scheduled the presentation time, so please stick to the deadlines.
And other authors are also waiting. That's fine.
Okay. So DZFD method is used. So first of all, we'll estimate and then subtracted. This is the ICI part, and then we'll get that. So this is my ICI free signals at the ith subcarrier, and then applying the diagonal edge reinforcing detection method. So because it is an ICI free, now we'll apply the DZFD in an iterative manner in order to get the obtained signals. So as the so we are considering only the diagonal elements and Q upper and Q lower diagonal elements. So in order to reduce the computational complexity. So in case of OIDF, PIC, DZFD, the method is almost the method is same. Only the initial signal detection method is used using OIDF, and similarly in OIDF, PIC, OIDF. So initially we will apply OIDF method and then cancel the ICI effect, then get the ICI free signals and apply the OIDF method in order to get the refined data signals. So this is OIDA PIC OIDA method, and the simulation results we have taken two transmit antenna, single receive antenna, F50 size 128 number of carrier 128 cyclic prefix 16 EPSK modulation, and then carrier frequency 2.5. So these are the simulation parameters we have taken into considerations, and this the results. We'll see that so MDF method is approximately the ML with very less complexity, and we will see that with I is equal to 2 number of iteration is sufficient in order to get its optimal value. And then we have proposed these red colors. And so DZFD, PIC, DZFD, OIDF. So these are the proposed method, and for normalized Doppler's frequency 0.06 and 0.12 respectively. And we will see that the proposed OIDF, PIC, OIDF method achieves very large, outperforms all the signal detection method, including time domain block linear filter and sequential decision feedback sequence equalizations. So this is similar with respect to normalized Doppler spread. So irrespective of any normalized Doppler spread, the proposed method achieves much better performance. And this is the computational complexity tables. So we'll see that complexity is in the order of n, whereas time domain block linear filter is of order nq, where n is the number of subcarriers. So now I want to conclude my presentation. So the STBC OFDM suffers from two types of interference in CCI and ICI effect. And to improve the system performance, we have proposed 3 iterative CCI and ICI cancellation methods. And we are comparing with the conventional signal detection method with optimal ML, time domain block linear filter, and sequential decision feedback sequence estimations with respect to similarity and complexity. And from the simulation results and complexity, it is demonstrated that the proposed OIDF, PIC, OFDF outperforms all the conventional signal detection method with significantly lower complexity. So these are the references for the paper. So thank you. Thank you, sir, for giving me the opportunity for presenting my paper.
Any question? Quick question from audience? We can take one question. Dr. Iyer, if you have a question.
No question, sir.
Okay. So we'll move to the next paper, and paper ID is 1501515. Miss Nawa,
hi.
Are you going to present your paper? Yes, we can hear you. Let me make you the presenter.
Dr.
Yeah.
Jyoti, you can just stop presenting.
Yes, yes.
I think I can the pre-recorded, but I can also do the presentation now here.
I have that presentation video, but if you can present here in live, yeah, then it will be fine.
Yeah. I will take the PowerPoint.
Now you can share your screen.
Okay.
Yes, it is visible.
Okay, perfect.
Everything is fine.
Okay, perfect. So good morning to everyone. I'm Eleonora, and I'm a researcher from the NTNU, Norwegian University. And today I'm gonna share with you the process and the findings of the study carried out with my co-author, Ashish Alote Parmar, which focus on visualization techniques in virtual reality to enhance performance, memory, perception, and perceived usability in a vocational educational experience. The objective of this study were to examine current advances and the state of the art on the impact of different VR visualization techniques for educational experience, and in particular to measure the influence this may have on performance, perception, perceived usability, and memory retention. So the research question is how different visualization techniques concerning display and interaction fidelity and visual diegesis can affect and improve these three distinct spheres of the young job seekers in a VR immersive job taste experience for a vocational profession. Literature research has shown that higher realism tend to improve a higher sense of immersion. The goal of current VR technologies is therefore to create environments that are similar to reality. And the chosen field of exploration was vocational careers, as there is always a high demand for workforce. Is a particular field, and there are a variety of different roles and jobs. In vocational training, VR is used to emulate and faithfully replicate potential obstacles in the workplace, and for establishing a standardized approach to training and realistic simulation of daily professional routines. What has been found is a gap in the classification of the different strategies and techniques in which VR can be used to enhance the learning experience. Additionally, the available research on designing VR experience for effective knowledge transfer is quite limited. The review consisted of a literature research of empirical or experimental studies from the last 10 years, with diegesis and realism as the main concept in the context of virtual reality and vocational education. The topic on which the review focused were related to interaction and display fidelity or realism, human factors, visual diegesis, human-computer interaction, and usability. The target user of the experiment identified were young job seekers, as they require more guidance and motivation, and VR experience can help them in an early training phase to support their decision-making. The research methods performed were expert interview to learn about behavior and motivation, user and usability testing of previous experience to identify limitations such as possible phobias, physical and technology problems and opportunities, and case collection of experiments to identify frustrations, problem, and opportunity. The expert interview with professionals aimed to identify general contrast and pattern, and the outcomes were the three tasks to be performed in the experience. The hypotheses were that the first states that providing a highly realistic environment in terms of display and interaction fidelity can enable users to gain a better understanding and comprehension of the simulation. The second hypothesis concerned having a high level of realistic environment and diegesis of visual element that can contribute towards user feeling more immersed in the virtual experience and having a state of flow. And the last hypothesis regards the adherence to human factor principle to enhance comprehension and enable users to achieve goals with the minimal mental effort. The two scenarios were developed with Unity software and Figma software. In the low realism scenario, on the top part of the slide, users interacted mainly with non-diegetic interface using the raycast to grab and insert object. And the scenario employed pop-up interface and non-diegetic arrows to guide the user through the experience. In contrast, on the bottom part of the slide, the high realism scenario involved the direct interaction with objects, including grabbing, moving, and using them directly, and relied on diegetic signage for user guidance. The protocol of the experiment includes the use of the device Oculus Quest 2 and a personal computer, creation of two immersive scenarios, one low and one in high in realism and diegesis, 3 comparative tasks for each scenario, 14 testers that were divided into 2 groups, and one group tried just one experience, and measurement tools as observation, time measurement, task performance, and post-experience questionnaires. The results of the experiment were processed, compared, and converted into visual graph useful for a better understanding of what was achieved. That is synthesized in this slide. In overall, what has been found is that on the level of cognitive engagement, as the low and high realism scenarios were carefully designed in detail, the impact is not as significant. The high realism scenario had just as slightly better ratings than the low one. The main difference is that a higher realism and interaction positively influence memory and knowledge retention, particularly when the user had to remember the action and the tools they use during the task. The study emphasized the importance on finding the right balance between realism, usability, and engagement to create effective VR experience. The main limitation is that as this is a pilot with the limited users, the reliability of the results can be further improved with increasing the number of user testing, and also the technology and rendering techniques can be further improved. The conclusion and the guidelines are that detailed interaction and fidelity and coherent narration can enhance learning and help as a higher engagement. A careful design system of feedback guides users through the experience and help them achieve their goal. And a consistent experimentation with the usability. So doing usability testing is essential for identify areas that need for improvement. Thank you very much.
Yeah, how many users have you tested it on?
14 tester. So
Pardon?
it's 14 tester. So 7 for the low scenario and 7 for the high. That's definitely a limited amount of user testing, and as a further experimentation, definitely the number should increase.
Okay. Have you received any funding for this project, or is it?
No, but it's a part, not my project, because it was a thesis project, but it was part of a European funding of learning technology enhancement learning project that is about vocational training. So it's not, I just add this scenario, I build this scenario with construction site, but they are working more on fish farm, what is more needed now in Norway.
Okay. I think so you can include more users, you can test it on more users, so you'll be able to get an idea regarding the actual outcome of it.
Yeah.
Any questions from the audience?
I think no questions from audience. Shall we move to the next paper, sir?
Yes, sir.
Okay. Thank you.
Thank you. So next paper is 17. Temporal contrast sets mining. Is author of 17 present here? Yes, okay.
I think so. There is. Yeah.
Yes, just let me make you the presenter. Okay, you can share your screen now.
Hi, everyone.
Hi. You can.
Thank you for making me a presenter. I'll be presenting our paper about temporal contrast sets mining.
Just one request.
Yes.
If you can turn on your camera, then it will be fine.
It's hard for the time being. So is it possible to just share the screen now?
Yes, it's okay, no problem. If you can, then it's fine.
Okay. My name is Mariam Orabi. I am a researcher in the computer science department in the University of Sharjah, UAE. This paper is done by me and my professor, Zahir Al-Akbari. The outline that we will go through is first, we'll go through background information, then motive and contributions. Then we will go through the approach and results. And finally, we will conclude and find future directions. For the background information, we'll talk about contrast sets. There are data classes, which means that data naturally organizes itself into distinct groups. Each group have unique characteristics and features. And for classification, we must analyze disparities among data groups' features. As in the example here, we have two data groups, small families and big families. These groups have certain attributes, which are income and qualification, and each one of these attributes has different values. So we want to find the contrasting sets of values between these two groups. So what are contrast sets? They are sets of attribute value pairs defined on different groups that contrast between groups, such as qualification equals to graduate and income equals to high. There must be a big difference in the probability of an object that has the contrast set and belongs to the groups. For example, given the contrast set that we just talked about, the possibility of having this attribute value pairs and being in the group of small families is high, but the probability of having this contrast set and being in a big family is low. Contrast sets are a special case of association rules. The motive of our work is that first, mining contrast sets is very important for several things, such as data analysis, unsupervised methods to explore data, feature selection for classification models to improve the efficiency and accuracy. The motive behind temporal contrast sets is that contrast sets are unordered. The temporal aspect of the items is overlooked. For example, the contrast set X of item values A and B is interpreted as A and B and is equal to B and A at the same time. However, if we have temporally ordered items, this is important for many applications, which means that we're looking at the contrast set X, A, then B, which is not equal to B, then A. So we are looking at the ordering of items inside the contrast set. This is important for many applications, such as disease prediction, where the order of the symptoms plays a crucial role in identifying specific diseases. This was suggested by research for identifying COVID-19 patients using the order of symptoms of the patients. Therefore, the contribution of our research is to propose a model that extracts temporal contrast sets to improve deeper understanding of temporal patterns within the data. The approach that we followed is as follows. We use sequential association rules instead of using traditional association rules. The sequential association rules have two types, one that considers time as an implied component and one that considers time as an integral component, which means that in the first one, the order or the constraint that determines the relevance between the items is time. And the second one, time is considered as an attribute. We follow the first category to mine sequential association rules and use them for the temporal contrast sets mining. In contrast sets, there are several terminologies that we have to define, such as the support of a set. X is the support of is equal to the frequency of the X happening in a certain group over the frequency of X in all groups. The contrast set should be large and should be significant, which means that it have to follow the following two conditions. The approach that we used is a tree traversal approach through the sets of item values. For example, we start by, for example, if we have A, B, C as attributes, as values, I mean, we start with A and we check if it's a contrast set. Then we go through its subsets, through its descendants, AB, then AC. If AB is pruned, this means, based on the previous two conditions, this means that all of its descendants will be pruned, so we don't have to go through them. And I just want to mention that the order of the items here are very important, unlike other methods that just consider AC, for example, and do not consider CA. The results, we applied this model over a data set that has 123 students' performance data from the University of Sharjah. We had 10 TBLs for Introduction to Databases course, and we tried to find the effect of the TBLs on their performance at the final exam, the sequential order of the TBLs. The grades classes are A, not A and F. This is a sample of the results. The results is longer than this. I just wanted to show a sample of it to show the interesting part of it. For example, if a student failed TBL number 6, then it have a very high probability of having not A on the final exam. But if the student had A on TBL 8, it means that they have almost like relevant probabilities compared to the previous one. So there's more probability of having A. However, if the student failed A, then failed 6, then got A on 8, then he loses the probability of getting A on the final. And the probability of having F is also less. And the highest probability now is having not A. Conclusion and future directions. We have defined temporal contrast sets mining, which is a technique that discovers ordered attribute value tuples and time-dependent datasets. It is applicable in various fields such as healthcare, education, traffic management. We developed a model for temporal contrast sets mining and applied it and validated it using a real student's performance data. The key findings that we got is that we extracted influential TBL test sequences to highlight contrasting characteristics between student groups. For future directions, we would suggest to apply the model to larger datasets to improve the model scalability, as it depends on a tree traversal method. So we suggest improving its scalability and efficiency and adaptation to big data. We suggest extracting temporal contrasting sets to diverse domain to explore contrasting sequences within different classes, not only for educational datasets. We would suggest extending it to adapt to data streams by incremental extraction of the contrast sets, and extend it to mine spatiotemporal contrast sets. Thank you all for listening.
Okay, what about you talked about the support here. What about the confidence level?
Confidence is not mentioned in contrast sets. It's just about support and the p-value. The p-value relies on the dependency of the contrast set of. I'll show you the equation to explain it better here. Here, we're looking at the probability of having the contrast set in a certain group, and we want it to be dependent on that group. We don't want the probability to be equal among all groups. So this is how why we don't have confidence here.
Fine. So actually, this is in contrast to clustering, because this is totally different from clustering. You want to have the contrasting set of that.
Yes.
Fine. Any other questions from audience?
I think there is no question.
Sir, I think we can move on to the next.
Thank you very much.
Thank you. So next is paper ID 187.
Yes, good afternoon, Dr. Patel. And good afternoon, Dr. Iyer. So
just a minute.
Right. So what do I need to do is I need to most probably go and make myself presenter, right?
I made you the presenter.
Yeah, okay, sorry,
You
right.
cannot-
So
just
how do I
now-
share the screen now?
Near leave button, you will get a one button with a share and up arrow.
Yes, sure.
Using that you can do.
Okay, can you see my presentation here?
Give me a few seconds. Yes, it is visible.
Right. Well, it's the
not
full screen here.
presentation. It's not presentation.
It is presentation.
It is presentation. Mechanical systems and signal processing.
No.
So you have shared the other windows.
You shared a separate window.
So what do I need to do is
you need to again.
Have you shared the window or have you shared the screen?
I shared the PowerPoint, so I think I need to go and
you can share the screen.
Share the screen, yes. I should have to share the screen, right?
Okay.
Yeah. Okay, now can you see the screen now?
Yes, I can see, but not presentation.
Yes, I'll do that.
Yes, now it's visible.
Okay, good.
Could you please turn on your camera?
Yes, I'll do that. I'll do that. So
thank you.
Now can you see me?
Yes, we can see.
Can you see me clear? Because I cannot see myself, so I don't know if I'm in the full
It's
frame
okay.
or
It's
you
okay,
can see
no
me.
problem.
Yeah, okay, good. Okay, so this is course study planning framework and engineering perspectives here. And this is me, Mohammed Shakil Agari, and these are other of my colleagues here. Okay, and I've been here for a very long period of time. A lot of research at this university. So I have a startup of our UAE universities, which I will share with you. It's not going down. Right. So it's the University of Future. We are doing a lot of things here with sense of research and teaching. And I'm sure if you can see the screen here, we were established in 1976. Now we have 14,968 students, which I founded today. We have students from 82 countries. We have 9 colleges, 9 research centers, 1 innovation park, and we are number 1 ranked in the United Arab Emirates. In the QS ranking, we are number 290. In the time higher education, we have in the 251 to 300. We are ranked 6 in the Arab world, and as well we are the top 50 universities of under 50 years of age in the whole world. And definitely we have a lot of students from India also doing PhDs, and not as much on the undergrad level, but at the level of masters and PhDs. This is our campus here. That's the administration building, and College of Engineering is there. This is our College of IT, and all colleges and labs and everything are there. Okay, so let's move on to my presentation. So I have an introduction, and I have the CSPF, which is Course Study Planning Framework Package. I'll explain that. And then I have 2 example cases, which I've taken from the paper. The 3 I've explained 3 there, described 3 there. 2 are explained, 2 will be shown here. And I'll have the conclusion. Okay, right. Students course planning and advising is an important as well as a trivial process that may encounter unnecessary graduation delays. We already know that. Typically when students and take our studies, and typically most of the students coming here, they have the English language courses in their schools, but majority of their coursework in the initial stages is in Arabic. So, once they come here and a lot of instructions are in English, typically we are English speaking university. We are not allowed, anybody is not allowed to speak Arabic here in the sense of teaching and explaining things to the students. So they miss the guidelines of how to register. They miss the guidelines of choosing courses precisely at the right time. So lack of proper planning and advising system, because this is the delays are because of this. Awareness and experience of advisors, again, because of some turnovers, new advisors are getting students, and the even those advisors are not aware of how actually how the courses should be selected. Students ability to seek good advice. Sometimes what happens is students, they feel like uh, they know everything, but that's not the thing, and they have to seek good advice in that respect. Inappropriate advising time schedules. So what happens is a faculty or an advisor have office hours kind of thing, typically for the thing, and students are busy at that time, so they're unable to come and seek good advice at the time. Okay, students may suffer. So if they miss right courses at the right time, suffer problems as course selection with time conflicts. So what happens? They plan this that for the next semester we'll be selecting such courses when the registration is announced or when the schedule is announced. They find these courses are in time conflicts. Missing out on suitable courses. What's meant by suitable courses is some courses are to be taken earlier, and some courses are semester specific. So if they miss out, they may miss out a whole year to have this course again. Choosing electives by passing track restrictions. We have two tracks here. We have a communication engineering track and we have an electrical engineering track. And what we have is, and then what they do is, because the courses are offered in the department, so they typically choose other restrictions, courses from the other track. In the end, they find out that they are unable to register for those courses. So what I'm talking about is not at the time of registration, but the time of planning. Selecting too many or too less courses. Too many courses, we can understand, it gives a heavy burden on the student. And too less courses, we have a restriction of 12 credit hours anyhow. So we cannot select less than 12. But then as we expect good students to select more than 12, definitely. But if they keep on selecting 12, they won't be able to finish their degrees in a long period of time. Selecting unnecessary incorrect courses, meaning in general education courses, some unnecessary courses, they might be selecting this thing. So in this respect, this course study planning framework is devised. Okay, so it's important for to explain the whole thing, what's happening in our university. We have 1,900 students, right, in the college. Electrical engineering and communication engineering department, we have about 400 students. We take 147 credits. Students take 147 credits. An average course load will be 15 to 18 credits hours per semester. And then it will be from 4 to 6 courses, often 7 with labs. And it takes about 8 to 10 semesters to complete the studies. Right, so 147 credits are distributed like this. University General Education is 21 credits. There are 7 courses there, including the English and others. Then we have a College of Engineering requirement courses, which are the base courses for all College of Engineering students, not a specific department. We have 5 departments here, and that is 41 credits. Then department compulsory specialization requirements. This is for electrical engineering, 52 credits. Elective specialization, there are 4 courses, so these are 12 credits. And then we have a 15 credit hours of industrial training, which has been now revised to have 3 credit hours of training. So we have modified a bit, but this research happened 7-8 months ago. So that's the whole issue here. So we still have 15 credits there. Even right now, all the students, so these 3 credit hours of industrial training will apply to the newcomers, not to the old people. Okay, so, and then we have 2 semesters of graduate project, which is 6 credits. Here I have put a course hierarchy chart here, and green ones are the college requirements. I've missed out some college which don't have hierarchies. I've not shown that, as well as the university requirements I've not shown here, but electives are here. And you see, most important thing is students missing in long hierarchies will delay the registration or will delay the graduation or may delay the industrial training is in the last 2 semesters. So typically that may be delayed because of this thing. Industrial training is just in the last year, and it's a whole semester wise training. So they may miss out, or even it's 2 summers now. Either you can have 1 semester or you can have 2 things, 2 summers. Okay, so the yellow courses here, which are the orange courses, are the electives. The blue ones are the requirements. And then we have industrial training, and after industrial training we have, or now industrial training is in the middle. In the summer also we can do industrial training. So graduation project one, which is elect 585 and 590. So the graduation industrial training can happen before or in the middle of the graduation project, or at the end after having the 2 graduation projects. Okay, so this is the what's this thing? The screen for how to select courses. This is the API which we devised. And if you really look at this thing, we have on the left-hand side, these are the courses for the college. We have 4 maths, 4 physics, and 3 chemistries. All are offered from their respective departments, from the math department, from physics, from chemistry. And we have general education, which is from our college, like engineering ethics is one of the courses, in engineering economy, thermodynamics. And then STAT 210 is from the stats department. The general education or the university requirements are shown below, like English ESPU 107 is there, and there are 4 general education courses. Then we have Islamic thoughts and cultural, the Emirates culture. And then we have a set of selections. So what the student will typically would do, well, I'll show you what the student is going to do is start the whole procedure, open the application app, the package, and then submit is to submit a semester's load. Courses, when I click on courses, it shows me a whole set of courses. I have shown portion in the next slide. Chart, I'll show you the chart I've already shown, and exits there. And this is the, if you really see, semester credit hours is shown here.